counterweight. Okay, so in counterweight what is happening? Let's say if you have one well bore water, right, you have that much of well, and you normally will have one pulley like this, and you have bucket, right. Right. So, when you are pulling water from normal well, so when you are pulling water, you need lots of energy. Take water out, again you are putting bucket inside, so that you can take water, right. So, when you are putting bucket, so that time you need very less amount of energy, only bucket weight will be there, and that rope weight will be there, so that will be going down slowly. Okay. But when water is filled, so that time you pull very high amount of energy is required. So, here also in sucker pump same thing is happening actually. When let us say this is going to your pump, okay. So, during downstroke actually you are not pumping, during upstroke only you are delivering fluid. So, during upstroke what is happening, this much of liquid is filled, okay, and there is no gap, I am assuming there is no gap, okay, and you are trying to lifting up, you are trying to lifting the whole fluid column up. How much weight will be there? Pressure, you know, okay, you know pressure, you can convert it into weight anyway. So, this much of pressure you are getting, you can multiply into area. So, that much of volume and pressure you are or weight you are getting. So, that much fluid you are lifting up. When lifting up, you need very high amount of energy, but when again you deliver, when you are moving down, so what is happening, this whole liquid column will be going down, plus rod weight plus plunger weight, everything weight will be pulling it down actually. So, that time you need very less amount of energy to put from motor. When you are lifting up, motor will be working very hard, and when you are lifting down, motor will be working opposite way. I mean it will be requiring very less amount of energy. What happens, let us say if I do not have any counterbalance mass, my system is like this, okay. I have motor and you are driving like this, no counterbalance mass, okay, horse it is here. So, during uplifting you need very high amount of power or energy, power is very high amount, but when it is going down you need very small amount of power, okay. Again very high, so power will be very high, small amount of power, high power. So, this fluctuation will go on. But if we do like this, when it is moving up, I put one very, it is moving up and I put very heavy mass, okay. When my fluid is getting lifted up, heavy mass will be pulling down there, okay, and it will be rotating also. So, heavy mass pulling down, when lifting completed, then again piston moving down, heavy mass will be moved up. So, when heavy mass is moving up, actually your motor is giving energy to heavy mass to move up, okay. Then piston move down, when piston again moving up, heavy mass going down, heavy mass is going down by itself, okay. So, that time piston is helping, heavy mass is helping. When heavy mass is here, let us say this is my heavy mass, okay, okay. Heavy mass when piston is moving up, heavy mass going down, 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 piston maximum distance travelled, again it will go down. When it is going down, this is going down, this is moving up, okay. Mass, heavy mass, or that is counterbalance mass, counterbalance mass will be moving down when piston moving up, when piston moving down it will be going up, okay. That is why your motor will be requiring half power. When moving up, counterbalance mass helping, when moving down you are giving some energy to store in counterbalance mass, okay. So, gradually so one half you are giving energy, another half you are getting energy. So, if you calculate total mass required for your counterbalance mass. So, total mass required to balance the counterbalance mass will be like total maximum force required to lift the fluid when you are going downward, maximum force required. So, total force plus total force average by 2, that will be your counterbalance mass. So, and whatever, then why motor is giving power if the counterbalance mass is doing. So, counterbalance mass one time helping, another time not helping. So, motor will be working continuously and will be giving certain amount of power continuously to lift the fluid. If it is not helping, giving that power, it will be stopping actually. So, counterbalance mask is helping to reduce the peak power requirement from the motor. If you are not giving counterbalance mask, peak power will be very high, so motor will not be able to help that one. But during downstroke, again you do not need lots of power, so that time motor is working, but the energy wasted. So, just to optimize this one, people will be using counterbalance mask, and counterbalance mask also they will be putting certain arrangements so that they can adjust the mask as per requirement. Okay. Crank, if you see IC engine term, the crank term is used, crank is here. Okay. So, crank will be rotating continuously and crank is connected to counterbalance mass. When it is moving up, it will be moving down, okay, just opposite way. And this is also connecting rod, and in oil industry they are using as a pitman arm. Okay. Now, I have seen this, we have seen this walking beam, and horse head is connected here, horses is going to bridle, bridle is connected to your polish rod, polish rod is going through one seal section. Okay. This is seal section, polish rod is entering here, is going out, and there will be one pipe going like this. Okay. And another pipe will be like this to gas venting actually. So, this will be tubing and there will be casing. This is wellhead. This is casing, so casing should have perforations. Okay. This is reservoir, PR, reservoir pressure, this is PWF, flowing pressure. I have tubing here, I have sucker rod here, sucker rod here. So, here this is called stuffing box. Why stuffing box is there? When fluid you are pumping and you are lifting fluid, this is a fluid. Okay. So, this fluid should not get spilled on the surface. So, fluid should get through the T junction. This is called T junction. T. Okay. So, fluid pass through the T, that pipe, side pipe is going. So, there this is gas actually, gas venting. Gas is coming through this. What happens when you are installing sucker rod pump? Normally it will be installed inside tubing, maybe tubing insert type pump or tubing pump, sometimes casing pump also available, but assume that this is tubing pump or insert pump. Now, fluid is coming through, your pump fluid is coming through tubing. So, tubing must be connected to your one pipe so that it can go to your separation system. Or, okay. And the casing area, there may be some gas accumulator, so the gas should be taken out from this gas line. Okay. So, this upper portion like T, like if you see like T, if you make vertical it will be looking like T, but they say T. So, the T section, what fluid will go out from the sucker rod pump, and stuffing box will be preventing liquid going out to the surface or spilled all around. What happens in stuffing box? Stuffing box actually like this, seal section, lots of seals will be there. Okay. So, this seals, and here this is called polish rod, this is polish rod. Okay. This is polish rod, this is my polish rod. So, what is polish rod? Polish rod actually very highly surface finished rod. Normal rod will have lots of surface irregularities. So, surface irregularity is there, and I have one seal section. Seal section means seal will not allow fluid to leak out, right? And this is my polish rod. Polish rod is moving up and down continuously. If surface is rough, what will happen? So, rough surface will be eroding the surface, sealing surface, and it will start leakage continuously. So, to avoid that one, seal surface must be made very smooth. If corrosion and other particles affecting the surface sealing, so in that case sometime you have to rework, or you have to get some coating, so that its surface will be very much smooth, so that there will be no friction or almost frictionless. So, if frictionless is there and it is moving up and down continuously, it will be lasting longer and there will be no leakage actually. Normal sucker rod pump, the sucker rods will have surface roughness, but especially this polished rod section, surface roughness will be very low, very good surface quality is required. So, in normal eyes, naked eyes, if you see any rod, any surface will be like smooth, but if you say using some electronic microscope or something, surface will be rough. So, in the polished rod section, people will be trying to reduce these roughness values, so that friction will be lowered and leakage will be lowered. And the seal section previously people were using cotton or some softer material, so that it can make a clearance free flow path for this polished rod. Polished rod will be moving up and down, and if soft material is there, so a negative clearance can be created. So, that negative clearance will not allow fluid to leak out. But if it is very hard, let's say completely metal you are making, so that means for mechanical reason you have to give certain clearance, so that will be giving some leakage. So, to avoid that one, you use softer material, sometimes cotton, asbestos or rubber. So, soft material will be used, multiple level of seals will be used, so that leakage can be completely prevented. In some cases, the people use energized seal. If high pressure is there, then a seal will be more active. Stuffing box T, bridle. So, bridle actually this is where, so this wire will be connected here, and this will be like this arc, this horsehead arc, it will be crossing through this one and it will be connected to your polish rod. This is called bridle or wear line. Okay. And horsehead, I already told, this is an arc, and it is designed such a way that it will be creating continuous bridle, and horsehead will be creating a tangent. Bridle will be tangent on the horsehead. So, whenever horsehead is moving up and down, it will be tangentially moving vertically up and down. So, it will not have any lateral movement. If lateral movement is there, so that extra force will go to stuffing box, and stuffing box will have more wear and tear, that will create leakage. So, that leakage is not wanted here. So, polish rod, I already told, the polish rod is a very good surface finish must have, and is the strongest part of a sucker rod system, sucker rod pumping, that power transmission system, and longer than stroke length, and it seals properly. Why strongest is required? Again, I will draw this one horsehead, bridle, then I have polish rod, right. So, when rod is moving upward, so that time you need very high amount of energy, okay, and high amount of energy, where it will be more? It will be in the piston or on the top section. Actually, it will be in the top section, because when it is moving up, so whole rod weight plus fluid weight plus other friction weight, all the weight will be held by this bridle and your polish rod. So, those will be very much strongest actually. Okay. Now, surface finish, already told, it must have very good surface finish, otherwise the wear and tear will be there, and it will be longer than stroke length. Let us say 74-inch stroke length is there. Stroke length, and we have one seal section, right, it is passing through the seal. So, stroke length 74, but sometime the stroke length can be changed also. So, it must be more than 74-inch, so that it will be passing through the polish rod, and it will be moving up and down continuously, and you will get enough stroke whenever required to increase or decrease, or maybe elongation or some other reason. If there is any change in stroke length, that will be accommodated, and it will be helping in sealing also in a stuffing box. Bearing, lubrication. Bearing will be there in many places. For example, I have a beam, saddle bearing is there, tail pin bearing is there, then crank pin bearing is there, then it will be having gear mechanism. Gear will have certain friction surface. Bearing is friction surface, reduce friction. So, bearing will giving reducing friction. Reduce friction. Okay. So, to reduce friction, when there will be two surfaces, one surface is rotating or sliding, or any motion is there among between two machine elements, so there will be friction. If friction is high, then what will happen? friction will be high, then heat generation will be there. When heat generation is there, spot welding will be there and surface profile will change. So, that will be giving premature failure of the systems. So, whenever there is high speed rotating machinery or slow speed machinery also, you have to check surface, we have to check whether it is lubricated properly or not. If not lubricated properly, you have to give lubrication. If surface is not finished enough, for example, polish rod, if surface finish is bad, then your wear and tear will be there in the sealing area. So, in that case things will go wrong, whatever you are expecting, leakage free system, so that will not occur. So, bearing will be here, here will be motor. So, there will be several types of friction surface. One shaft is rotating, another shaft is sliding, or another machine element is sliding or rotating, or maybe combined together. All these surfaces will give friction. When friction is there, heat generation will be there. So, energy loss will be there. So, you have to reduce friction. Okay. How to reduce friction? You have to make surface smooth. To reduce friction, smooth surface. Again, another thing, instead of sliding contact, you can make rolling contact. What is sliding contact? What is rolling contact? Let us say one shaft is here, okay, and is passing through certain bearing, okay. Shaft is there passing through this one, rotating, okay, like this. So, what will happen? It will give lots of friction. But if I make surface like this, small balls if you put, like in cycle you have, right? And if you rotate inner circle one, quickly it will be rotating, because I am giving rolling friction. So, surface friction will have lots of friction, energy loss. If I give rolling friction, instead of surface contact, I am giving rolling contact, okay, or point contact or line contact. So, in that case my friction will be reduced. When my friction reduced, life is good. But if I have friction high, then energy loss will be there, machinery life will be lower. Okay. So, there are different types of bearings will be there. One will be journal bearing. So, there will be no balls or anything. So, just it will be rotating continuously. Okay. It will be rotating continuously. But in certain cases, I need very much frictionless surface. So, in that case, I will be putting lots of small balls. When I will be putting this shaft inside, it will be rotating. So, smoothly rotating, because your balls are there, it will be rolling quickly. Okay. So, in that way you are reducing friction. Another ball is there, still you need lubricating oil. What is lubricating oil? Lubricating oil is actually long chain hydrocarbon. Long chain hydrocarbon. Hydrocarbon. Okay. If it is oil, then it will be long chain hydrocarbon. So, if you go to any motorcycle shop, car shop, they will have liquid like castor oil and mobil oil and all these Indian oil. They have many companies, they are having lubricating oil. That lubricating oil means long chain hydrocarbon. So, those chain will be sliding over each other and it will give frictionless surface. How does it work? Actually, normally naked eye surface will be like this, smooth, but if you take microscope, surface will be like this. So, if I have long chain hydrocarbons, long chain hydrocarbon will be filling these gaps actually, and when two surfaces are meeting, so in between the two gaps, one thin film will be created. So, two surfaces will not match each other, rather a thin film will be creating some difference, and the thin film will have their own molecular layer. So, molecular layer will be moving over each other whenever moving or rotating, whatever you are doing. So, they will create certain gap that will be giving frictionless surface actually, frictionless contact. But if you are reducing that lubricating oil or lubrication film, then again friction will be increasing. So, whenever you are considering lubricating system, so you have to check temperature, you have to check how much load you are applying. For example, if you have very high load, for example, sucker pumping motor application, so in that case liquid lubricant may not work. So, in that case you have to use solid lubricant. For example, graphite can be one lubricant. Example, graphite solid lubricant. Okay. And liquid lubricant, I already told that normal long chain hydrocarbons will be there. Sometimes semi solid lubricant, grease will be there. If you go to any cycle shop, they will be putting some thick semi-solid lubricant on your cycles. Those are semi-solid. Some moderate pressure is there and it will not go away because semi-solid, it will be sticking your system. So, it will be lasting longer actually if you are for cycling application, but you do not use graphite for your cycle application because it will be almost dry and you cannot you are not using so much pressure. So, that will be effective. So, in that case they will be in cycle shop, they will be using liquid type or grease type lubricant. Lubricant is to create a thin film between surface that will reduce friction. If friction increasing, heat generation will be increasing. So, spot welding may be possible and surface wear and tear will be more. So, there will be problem. Okay. And heat generation is there somehow because of any reason, then you have to use some cooling mechanism. So, lubricant many like IC engine, motorcycle, cars, they are using as a cooling agent also. Actually, normally in IC engine later we will discuss, when crank is rotating continuously, so crank will be going to piston, that crank will be giving splash of lubricant going to piston, it will be washing some heat. So, that way it will reduce temperature also. Okay. So, lubricant is reducing down temperature, reducing friction, it will be giving frictions less surface, creating smooth thin film in between two surfaces. Okay. And if I see bearing will be different types. I will tell the journal bearing. This type of will be journal bearing. Journal bearing. So, normally there will not be any ball or roller element. It will be only surface to surface contact. But if you have rolling contact or point or line contact, so in that case friction will be low. So, this will be ball bearing. Ball bearing. Bearing. So, bicycle or motorcycle, they will be using lots of ball bearings actually. If you in cycle also, like so after summer vacation you come to college, then you see cycle is not moving, it is creating noise. So, what you do, you go to cycle shop. So, what will they do? They will remove the balls, old balls, they will clean, they will put new balls and they will put some grease. Okay. So, new balls they will be putting some grease and then cycle will be very smooth running. And sometimes your chain also it makes noise. So, again it will be when it is making noise, actually friction is happening, that is why noise is coming. Friction happening means lots of energy you are giving, but that is not converted into your rotation of wheel. So, you will be working more, but your cycle will be moving less. So, in that case what we will do, you put some grease, reduce friction, cycle will be moving smoothly again. Okay. But if it is high speed machinery, it will be creating very large amount of heat. So, that will give failure of whole system, but cycle is low speed machinery. So, whatever heat is getting generated will be getting dissipated quickly in the environment. When it is dissipating quickly, so heat generation may not be so much problematic, but high speed machinery heat generation can be very high. It will create welding also, metal will be melted and it will create spot welding and whole system can fail actually. Okay. Now, sucker rod pump we have seen API RP, API 11. So, normally API RP recommended practice, RP means not rod pump, it is recommended practice. API recommend American Petroleum Institute API 11, they will have series of documents. So, that will be specifying your rod, sucker rod size, your plunger size, your pitman arm size, all these sizes and calculations and dimensions they will have reported in tabulated form. So, one designation people use normally for sucker rod pumping calculation, this designation is also taken from API and it is like C will be your conventional pump, C will be conventional pump and D will be double reduction gearbox, double reduction CTION reduction gearbox. Okay. The other term, if I use M, it will be Mark II lubricants. A is for air balance, C is for conventional unit and B is for counterbalance unit. Okay. And the field second code peak torque rating in thousands of inch pound, and PL polish rod rating hundreds of pounds and this is stroke length. Okay. So, if I give this designation in exam, so you should be able to identify and you should be able to take the values. Okay. So, for detailed you just follow the book of Guo et al. Guo Galambur, Patel and Production Engineering, that book you can follow. Now, see the lever. So, you have seen this picture, right, horse head and going like this, and load is here, right. So, class 1 lever, first class lever, this is conventional unit. Okay. Class 3 lever or third class 3, first class or class 1 lever, class 3 levers will be like air balance unit, or Mark II. Gearbox speed ratio will be 29:1. So, that much of speed reduction also possible using double reduction or triple reduction gearbox. Whether for long stroke sucker pump can have stroke length 20 to 25 feet actually. Normal conventional sucker pump stroke length will be like 40-70 inches only. So, it's very long stroke sucker pump they have designed. Thank you very much.